Sure. So I'll start with the recording. So what I was saying. In the first go, you might think of that the BZ might be best for you or LZ might be best for you, but it's always good that you try a sample job on some of the sample data, find out the stats, compare the stats, and then come up with which is the compression technology which you want to use. That might also be chosen on different criteria like your file sizes, your cost which you are paying to the vendor for the hard disk or the CPU, the availability of the RAM, and the number of users in the cluster, the time where then you're using, and a number of things. But yeah, if you understand how these compression works and in which phases they can be applied, definitely you can think of those things. So, but there are two compressions which are splittable, two which are not splittable. Anyone want to recall them?
Yeah, BZIP is splittable, and for the GZIP you have to have indexing on to make it splittable.
No, got it. Yeah, BZZip2 is splittable, but LZO is splittable only if the files are indexed. So there's an option to index the files, and if LZO files are indexed, they can be splitted while reading. Okay. So I hope, Chand, you are back with your headphones. Okay, Basha will be back, I think, in a minute or so. So, okay. I'll just wait for him for 1 more minute to get his headphones back. So, and then we started discussing about the file formats, and then the match started, and everyone just wanted to move away. And unfortunately, we did not reach the Australian New Zealand level.
Hello?
Hi, Chand.
Hi, Miraj.
Hi. So we were just discussing or recapping what we discussed in the last class, and let's start with the new topic today. So we discussed the compression in the last class. Now we are moving on to the file formats. So we started sequence file, but I hope most of you have not heard about the sequence file, and let me recall everything what we discussed in the sequence file before going ahead. So sequence files are used as a container of small files. They can they are mostly used as a container for smaller files. You can seek in between the files. You can sync with the block boundaries. You can use the sync pointers in the files to if you are lost while reading up big files and things like that. They offer you block and record level both kind of compressions. So how that is done? Let's look into that part. So this is a kind of file where we have the header, the records, and the sync pointer in between. So header contains your name of the key and the value of the classes, the classes which are stored in the value. Compression details, user-defined metadata, compression codecs, and things like that. Your record contain your real record, that is a key and value pair, and the record structure is something like this: record key length, record length, key length, and the key and the value. If there is no compression on record, and record length is the length of the record, and key length is the length of the key. And then if you have the compression, then the compressed record would look something like this. The record level, the record length, the key length, the key is not compressed, but the compressed value. So this is how these files store your data in the real file structure. And with the help of this syncs, the third pointer over here, this helps you to sync your data. If your pointer is lost somewhere in between, these sync pointers are used to resync the pointer. And I hope you understand this seek time in our in reading the data is higher as compared to read the data, and it's difficult to reduce the seek times, and that's the reason we discussed we have big block sizes in Hadoop cluster as compared to the other file systems. And if you have the block level compression, the thing would look something like this. You have blocks. Block will have number of records, and So the block would look something like this: number of records in that block, the compressed key, the compressed key length, compressed keys, compressed value length, and the compressed values. So this is how your block level and record level compression looks inside the files. And these files are used as a container. So in the record, in the real value, you can store your smaller files or big files like images or a number of things. And
so in the block level compression, the keys are stored together.
yeah. So in the block level compression, say there are n number of records in this block, so n number of keys would be compressed together in the block.
So, Miraj, one question. After compression, why the record length is same?
After the compression,
In your previous slide, can you go back to previous slide?
yeah.
So here, record length, no compression 4, and record length is still 4.
That is the length of the record. That this is the length of the. I think
the size of the
okay.
record.
Okay, here this is what you're pointing. Okay,
Yes.
this record length is okay. I think this should not be 4. This is wrong over here. This would be changing, and this would reduce to some other level. This is just a 4, which is figure I think pointed over here. But this would be something else over here, and this would be something that 244 something like that. And this would be compressed after compression. It would be reduced to some other value.
Okay. Okay. Good.
No, it's just the length of the record. So let me show you an example. Just give me a minute. Let me open the Eclipse and show you the example.
Hey, Miraj.
Yeah.
Hey, is there anybody having problems connecting to GoToMeeting?
With when I joined the GoToMeeting only as problem like.
I basically launched the GoToMeeting. It's basically saying error connection to server could not be established. Anybody has joined the?
Are you using the latest link that you have been using for 2 weeks, or the first link?
Not the latest one. The one that actually is the latest one.
Is the meeting ID ending with 885?
Yeah, that's the one I'm using, and that was the last time I used it.
If you are connected to any VPN or anything, because I had that kind of problem.
Yeah, I restarted a couple of times. I restarted my machine like a couple of times. It just comes and it says error establishing connection, and I had to keep trying like multiple times. And so you guys all in the meeting, right? Like it's not something that.
Yeah, and yeah, you are connected via phone or what right now?
Right now, I'm talking over the phone. Yeah.
Okay. You can try at the backend. By the time I'm sharing you one link, let me share your join me link where you can see my screen, and you can use that link for a time being. You can just go to join.me and just type the IP address which I'm giving to you. In the meantime, just try with the GoToMeeting. Give me a sec. Let me open the GoToMeeting also. Sorry, join me also. So in the meantime, you just go to this thing. Join.me is a website. Just go to that website, join.me.
Okay, it says start meeting, join meeting.
Yeah, join meeting. Inside the join meeting, give an address 173.
Okay.
-222 3 times 2.
Okay.
-869, and you would be able to see my screen.
Yeah.
Got it?
which I think is coming.
Yeah. So meantime, in the meantime, you can see it by this, but just try some issues. I think it's over there only.
Yeah. That's
Sure. Okay.
Thanks.
Okay. So let's, before reading it, let's look at the writer. Okay. So here what I'm doing is I'm just writing some data, something like this, one to my buckle shoe. That's just an example which I'm writing up, and writing up this data into a sequence file. And so what we're doing is we are creating one key. Key is nothing but the line number. Yeah, key is nothing but the line number kind of thing, and the data is something like this. So we're just putting some random data out of these 5-6 text and storing in the file. So let me try to run this program. It's a simple Java program where I'm creating sequence file. You can create it a number of ways. I'm just using the Java program. When we'll be looking into Hive, we can directly create it. We can just say the table format as sequence file, and we can create it similarly from other ways also. But over here, I'm just using the Java program to create a sequence file, and then we'll look into the how this what do you call it? Sync pointer helps you to read the data fastly if your pointer is lost. So let me try to run this program, and for that, okay, let's start it up. Okay, and I'm using this location. Before that, let me delete this location. So in this other time this will run, we'll look over there. So by the time it's running up, what I'm doing over here is I've created a sequence file writer, sequence file writer.create file. This is deprecate function. You can use the latest one. And here I'm just giving the file system configuration of the Hadoop HDFS file system, and what is the key and the what is the and just doing value.set and writer.document. They're just simple as any other file writers work up. Same way this is a writer in Java. So using that to create a sequence file, and okay, so the file is created and it is printed on the console also. I'll just show you the file also in a minute. So this is the file, and 1, 2, 3, 4, 5, 6 like this, and the this 120 is the byte offset over here. So if you write count from here to here, I think probably 128 bytes, and then so on. So there's 128, 173 is the byte offset till the end, and these are the keys which are given to this these rows. So Hadoop fs minus ls. If I look over here, there will be one file, and if you try to read that, we'll not be able to read that, read anything over there, because that's a kind of sequence file. So okay, so output is the file name. Okay, so I do a cat. So it will just print some kind of junk characters. If I look at the file, I think probably text works with a sequence file. I'll just cross check, I'm not sure. Yeah, so here's my file, which was stored basically in this format, binary format at the backend. But the text command of Hadoop basically converts it to a text format. It uses the corresponding codec to date it to and show in the file. So this is a file which I was showing you. These are the keys, these are the values, and these are the byte offsets which we just generated it from the program and printed it over here. Now let's look into another program, and that would make more sense to you. So now this is a reader, same way as the reader class is used, sequence.reader, and we are giving a file to it and reading it one by one. Let's look into the seek and sync. So now I'm trying to seek something. So here what I'm saying is seek the position with the record boundary, and let me run and then show you the code. So what I'm going, let me give a record boundary, say 4187. So 4187 record boundary I'm trying to seek, and it's the starting of this thing, so it will probably give, so I gave 4187 as the byte offset which were printed over here, and there will be some stars also. Let me show. Okay, and the reader, there are the stars also. I'll show the reader also in a minute. So I've just given the position from where I want to seek it, and I got something. I got the record from that seeking position, one record from that seeking position. Now let me run the reader and show you one more thing. So in the reader, I am not only printing the file, but I am doing one extra effort over here. I'm printing the file, as well as I'm printing one star over here, which is showing that here the seek pointer is also there, other than the records. So if I, oops. I'll rephrase what I'm saying right now, then it will make more sense to you. But just look at these four examples, then I'll rephrase what I'm saying again. So you can see at some of the byte offsets, I'm printing the stars also. And over here, so these are the seek pointers, what you have seen in the PPT. So these are the sync pointers. So these are your sync pointers, which are pointed as star over here. So that we have figured out in the code. If there's a sync read, sync scene over there, we are just printing a star as well as the byte offsets. So in the previous example, what I did is I gave it it read 4187 position, and it read 4187 position and printed 1356 pick up the sticks. It's printed 56 pick up the sticks. Now let me do one thing. Let me try to seek from in between somewhere the record. So 4180 I am giving up 4180. Yeah, it is in between this 4140 and 4187. And I'll not be able to read it because I can't read from in between somewhere. So it will give me an error. So I got an error. Now what I'll do is I'll use these sync pointers. So here what I'm doing is if I'm lost, If I am lost, I'll re-go to some other sync pointer, which is the nearest sync pointer, and I will start reading from there. So even if I try to seek the file from in between somewhere, I would be very easily change my header to some sync pointer and can start reading up. That makes your reading of these files very faster if you are lost somewhere in between the files. So here what I'm doing is I am resyncing the position reader.sync, and after syncing up, my pointer will be pointed to the next sync available sync from that location, and it will start reading from there. So let me show you this thing. Let's give something like let's give 3981. So it will not be able to find this 3981 or 82, and it will sync it to 4075, and it will start reading from here.
Hey, Miraj, are you sharing your screen? Because I see the Eclipse, but not your terminal window.
Yes. Screen is shared. Is the screen not?
What I see is just the main method on the sequence file reader, and it's just a Java code.
Strange. Is this the problem with everyone, or is just the Karthik who was not able to see my screen?
Okay, now I see it. After I refresh it, I think I see out of memory error, right? Maybe I think it's just a refresh time.
Okay. Yes,
I think we can. I think we can see. I think it's only with join me.
Okay, yeah, join me might be running. Let us probably it also not run slower, but might be. But join me is very good. That's done pretty fast.
Miraj, I have a question.
Yeah.
So the sequence file creation uses the compression scheme defined somewhere, right? So where do we define the compression scheme, such as LZO or BZ2?
Yeah. So that thing you can so there are two things which we are talking over here. One is, say I'm on the Windows, I'm creating a text file or a Word doc or PDF, and then I'm using WinZip or something to compress it.
Oh, I see. Okay.
So here I'm talking about the file format. You can use you can compress those files with the help of any of the compression technologies. What we discussed previously, these are the files which you would be using in the Hadoop ecosystem that might be beneficial for you in different kind of work which you are doing.
Okay.
So, Karthik or who was it? Umesh or Karthik who was facing the issue with the screen sharing?
Umesh.
Umesh, I think you are joined on the Join Me, but Join Me also is very faster. I'm not sure why you're facing that problem. Just check somewhere problem with your network connection. That is all I can think of, because you are not able to join the GoToMeeting also. And
right. I see the Join Me now. I think I see your terminal window.
I think yeah, Umesh, better just download the Join Me. It's just 1 MB, 2 MB software, and that works much faster rather than opening it on Chrome or IE. We do a lot of meetings with this Join Me, and much faster, very fast.
Yeah.
So let me rephrase or reiterate what I said. So what we ran is the 4 examples which we ran over there. In the first example, we just use normal Java code to create a sequence file. I am not going into Java program right now, but I just wanted to show you how the sequence files work. In the second example, I read that sequence file, and I not only printed the byte offset of the file, but I also printed some stars which were showing that this is the sync pointer, or this is from where this is where my sync pointers are there. In the third example, we ran the reader to read some record from the file, and we gave it a position which is the start of a record, and it read successfully. In the fourth example, we gave it a position somewhere in between the record, and it failed because it was not able to find the headers and other things which I showed you in the file example, how the file looks like or how your records look like in the file. And in final example, what we did is, if we are not able to find the record boundary and we are lost or we are at some wrong location, we just move the pointer to the next available sync position, and now my pointer is synced, so I can start reading my file quickly. That is what I wanted to show you, which is the major uses of sequence file. Also, these files are used as your containers of a smaller file. So probably you will be using a sequence file when you are working with some other files which you can't store directly, or you think sequence file is a better container for them, mostly in cases of images or video files kind of thing. Any other questions?
Nope.
Okay. So then there's something called map files. Map files is okay. So basically, what these map files do is they create an index along with your data also, and with the help of index, your lookups are very fast into your real files. So we have an index file and the real data file, and when we want to read some key, we first look into the map file, we figure out where that key is, and we directly go to that position in our real data file and use that. Let me show you an example again over there. So let me create a map file and show it to you how they look like. Okay. What is the job name? Don't worry about these Java codes and things like that. You just worry about this thing, understanding the files. Okay. So so I'm just deleting the output location again before creating the this map file. So now the file will again be created as output location. But at this time now there will be two files. One will be your real data file and one will be your file which contains your indexes. So what I'm doing is again the same kind of value data which I'm using is just some random of these variables one by one, and giving them keys and value pair. Keys I'm just creating from 0 to 1024. So 1024 records total, and these are the values which I'm giving to keys one by one. Repeated fashion, but we created in the previous file also. But this here we are using the map file rather than the sequence file. So this is created. Hadoop fs minus ls, and over here if you see there will be two files. Now one will be our index file and one will be our data file. So see the text file and data file. Hadoop fs minus text. Let me first print the data, and then we'll look into the text file. So this is the same file again from 1 to 1024, total 1024 records, and these are the values given to these records in a random fashion. And let's look into this index. So index file will not have your all the keys and the corresponding byte offsets, but they will contain your keys, only a part of your keys. And so see, there are only 1, 2, 3, 4, 5, 6, 7, 8 records over here. But when I am saying I want to read key, say 101, say 500. So what it will do is it will start reading the index file. It will read the 4 files, 5 lines, and over it will find out that the 500 record would be coming somewhere in between these 2 byte offsets. So it will start reading from here, and then it will just return your key with the key 500 and the corresponding value. So if you want to read something, it will first refer your index file, and based on the index file, it will look into your real data file, and your lookup is very fast as compared to any other file. And I hope you understand. We are using the index over here. Okay. So RC files. This is an interesting thing, and there are a lot of other columnar file formats which are used highly in the industry, and RC is the most common out of them. So let's look into this. This is also an interesting file format, and so record columnar file. And can anyone guess what exactly this record columnar, what it says, what it could be?
Record column.
No idea.
Okay. So what happens in your traditional RDMO systems is you keep your rows in the file. So I have to print or store some row in the file. I start from column 1 to column 10, or there are 50 columns, column 1 to column 50, and then again for the next row, column 1 to column 50, and so on. So there are a lot of generic problems with these files when we store data in such a format, and what is the benefit if I store it in some other fashion?
So I think the drawback is if there are missing columns, then you still take that much space.
Yes, that is one drawback. But there are other drawbacks also. Let me talk about them and what is the benefit which you get. But yeah, that's one of the disadvantage definitely. Okay, so I hope you understand what I'm talking about. Let me not read this. Let me show you the real example. So say this is my file, which contains column 1, column 2, C1, C2, C3, and C4, and the corresponding value. So there are 1, 2, 3, 4, 5 rows, and the corresponding value is the row number and the corresponding column number. Row number, column number, row number, column number, row number, column number. So these are the 5 rows, say in my table, and this is how my table is looking like. If I have to store this file in some traditional RDMO system, I'll be storing it something like this. From here again, then from here, and then from here, and from here. So this is how my file will be stored in the traditional RDMO system. But when I'm using some row columnar file format, what I'm doing is I am dividing my data horizontally as well as vertically. How horizontally, I'll just talk about that. And vertically, what I'm saying is rather than storing my data like this, in this snake fashion, I'm storing my data something like this. So first I'm storing 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, then 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, and so on. So I am dividing my file. I am dividing my file horizontally as well as vertically. Vertically, I hope you understand. How horizontally, I just talk about that. And the benefit which I get over there is I am just storing the columns one by one. So can anyone guess what are the different benefits other than what Karthik just now pointed out? If I store my data something like this.
So if you want to only select a few columns, then you can do it faster.
Perfectly fine. Yeah, that is the greatest benefit which I get over here. Now I hope we started from the file systems. Now we are again moving to the file system world. In between, we have a big era of traditional databases and things like that. But again, we are moving to the file system kind of architectures. So yeah, this is the greatest advantage which I get is if I have to read say column 1 and column 3, my seeks are very less as compared to if my data is stored in the traditional format. So if I have to read just column 1 and column 3, my seeks are very less. Any other advantage can anyone think of? This is the one of the greatest advantages, Karthik. Compression. Anything clicks on the compression?
Because they are of the same type, it can be compressed.
Compressed highly. Compression is very, very good on these files because I'm compressing the similar data at one go. So I'm compressing this data would be a similar format. So the compression ratio would be much higher as compared to if I compress this data. So these are the two greatest advantages of using these files, and when you are dealing with high level technology, when you are dealing with your data in a table format, RC file formats might be much useful for you, and you might be storing your data in RC file formats to make your queries run faster. But again, it will totally depend on you what kind of queries you want to run on the data, what kind of things you want to do on the data. But this file format you might be using when you are dealing with your data in a tabular format. So how horizontally and how vertically? Vertically, I hope you understand. Horizontally, I'll just talk about it in a sec. So however, the row-oriented horizontally. So this I'll just talk about the horizontal partitioning will partition data. Okay. So what we do is we basically do a row group, and the row group size is again can be defined. What is a row group? So something like this. I grouped. So my row group is 3. So my data is grouped into 3 rows at a time, and that data would be stored. So this is my first row group which is created. This is my second row group which is created, and then I'm storing my data something like this. So the benefit of dividing it horizontally, I hope you understand. If I have to add another row, I am not again doing in between file writes and things like that. And secondly, my reads are much faster if I have to read a group of rows. So we don't only divide the data vertically, we also divide the data horizontally, and we get both the benefits of what we get in the traditional file systems as well as the benefit of storing dividing it vertically. So we create the row groups as well as the so the row group size can be defined up. Okay, so these are the row groups, and this is how your data would be stored rather than like this 1 1 1 2 1 3 1 4. It's stored like this 1 1 2 1 3 1 and so on. So now within each group, so columns can be compressed to reduce the storage space. Just talk about that. Since the data is column, so I hope you understand the compression would be higher because I'm compressing the similar amount of data. So my zeros and ones could be matched much faster, and my compression ratio could be achieved much higher. So, and then your I/O cost would be reduced. If you are reading some particular columns, my seek time would be reduced if I'm reading some particular columns from the file. So that is what I'm talking over here. So this is an example of your row-oriented systems and column-oriented systems. So your row-oriented systems will store your data something like this. Your first row is 0, 0, 1, 10, Ismail, Zo, your second row, and so on. Your column-oriented data would store something like this. One column, second column, and so on. And if I have to search something, I can just start seeking from particular position and can read that whole column for 1 row or 5 row kind of thing. And the benefit is my seek is very less. If I have to just read some particular columns from my file or data, my compression efficiency is very high.
But from the looks of it, it appears that the row number and row number is repeated so many times, so I think it will take a lot of space, right?
So this is just an example. Practically, it would not be like this. And just this is an example which I'm putting up. This is how it will look like. Practically, it will not be
Okay.
not be storing like this.
Okay, okay.
So any other question on the RC file formats?
No.
Okay. Similarly, you can just Google out Parquet. This is also hard today. Currently, it's highly used in the industry. You can Google out Parquet. I am not covering it over here, but that is also nowadays coming up and used highly. But ORC is also pretty good on top of RC. So it's optimized row column. The file is more optimized, and this is available in your Hortonworks 2.2. Yeah, the one which I've shared with you, the version is available over there. So I'll not read this whole text. Let me show you this example. Then we'll come to all this text. So what happens up is your data is divided again. That horizontal vertical partition is there. Your data is again in the RC format. But other than that, there are few other things which is available in the file. What is that is we create an index also. So when I have to search something, rather than searching that whole these row buckets that I've created in the RC file, rather than searching that whole row bucket, I just look into the index of that corresponding row data and see if the corresponding record criteria or the search criteria matches as per the index data. If that does not matches, I just totally skip that record row data. So this is the greatest advantage of ORC over the RC. There are other things also stored in this file, but the greatest advantage is we not only store the data, but along with the data we are storing index of the data. So that is what I'm talking over here. It contains your min, max, sums of the data, column level aggregations. So if I'm doing some, if I'm running some queries, say find employee where employee salary is greater than 5,000, I know what are the min and max values of employee in this row data. If that matches the criteria, then only I'll be reading this whole record. Otherwise, I'll just get this whole record. And these files are by default compressed. You can disable the compression by just saying that the compression is not enabled when you're dealing with high. And you can define a number of different compressions as we discussed. So the default compression is ZZip most probably. I'm not 100% sure, but it's most probably ZZip only. But you can change all those things. Everything is configurable. So ORC is much better than RC. I hope you understand, and it gives you higher compression ratios also. As compared to RC, because there are other optimizations in the file also. I'm not going into the details of the file structure, but the benefit is this thing, what I've shown on the screen. Then we have this last file structure, that is Avro. Avro you might be using up when you are, so this was created by dog cutting because they have to share their data with a number of different teams, and teams are working on different technologies. So they wanted to have some file system which is not only splittable and supports compression, but also is technology or language independent. So if I create the Avro file from Java, I can read that file in my C program. So that is what you wanted up. So not only platform independent, but the language independent. So Avro is a file system which is used for that. If you have to share your data, Avro is highly used in the industry if your data is shared across different teams and things like that. So similar to other file systems, it also contain your metadata and things like that. Supports compression, or splittable.
So quick question. So when it supports compression and also is splittable, then you don't have to worry about gzip or lzo, which doesn't support you can use any compression technology that doesn't support splitting automatically, but Avro automatically helps resolve that.
Yeah, so that so that is what we discussed over here also. If I do a record level compression over here, again I don't have to worry about my split table and a sequence files also. So
Okay.
there are two things. I created a text file or I created a doc in my Windows and zipped that. So that is a single zip which is created on the whole file. But we can, with the help of these unique file formats or file types, we can enable compression at different levels also. So here my files are splittable with the beauty of the files, not with the beauty of the compression.
Okay.
So that's why I was keep on saying that you have to precisely choose your compression based on n number of criteria. So although you would say that ZZip is not good because my file is not splittable, so that might not be the criteria because you might be applying your compression at a particular level of file.
Okay.
So, but I think you raised a good point, and that was not. I might not have made that clear in what I was saying, but definitely you raised a good point, I think.
You are going blank.
I was just skipping the PPTs, going back to the Avro slide, so it might take a sec to refresh on your screen.
No, your voice was going blank for some few seconds.
Strange, man. Okay. Is it clear now?
Yes, yes.
Okay. Okay. So it's not only platform independent, but it's language independent also. And that is the problem which I was telling you. The plain text and Java writable. So if I select some file in Java, I can read that file only in the Java. So that is a major problem which they were facing when they wanted to share files with other teams and things like that. So they came up with Avro file formats, which are not only platform independent but also your technology independent. So a file created by any of these languages could be used by any other language.
Do we have an example for Avro?
Avro, right now I don't have a Java code, but I can show you. Well, we can create the Avro file with Hive or something else.
Okay.
So now, and another beauty about Avro files is schema resolution. So say I create an Avro file. So what the Avro file does is basically they not only store your data, but they also maintain the schema with which the file was created. So if say today in my file there are four columns or 4 different data in my file, data types in my file. Say one is my employee ID, salary, department. So say these are the 3 fields in my file or 3 columns in my file, and my file is created by some data is pushed into my file for only for these 3 columns. After a month, I added 4th column, say employee surname. So as my file not only contains the data but also with the schema, so my reads and writes do not fail if my schema changes. So your schema is also stored with your data. So if you are using the new kind and trying to read your old data or vice versa, the read and writes will not fail. They will be taken care with the beauty of the file system. So that is one more beauty with this file, and that's the reason I was saying while we started this file system that they are highly used when you have to transfer your data or share your data across the team. So even if you change the schema, the read or writes of the other team do not fail. So see, this is a text file, RC file, encoded. Parquet, I told you Parquet is also these days highly used. This is again a kind of columnar file only, and ORC. With the beauty of ORC file, you get compression up to 78%. So, but again, there would be other factors like your decompressing the data and things like that. So again, you have to choose a file format also precisely as you have to choose your compressions, and the combination of both would make your system much faster. You can, there are drastic changes in the system by choosing the correct file format as well as the correct compression. I have seen some of my jobs running. I give you one example. One of our job was taking approximately 8.5 hours to do some data processing on that was joined it between 2 or 3 tables. We changed the file format as well as the compression, and that the job was, the time of that job from 8.5 hours was reduced to less than 10 minutes. So you have to think of the file formats, compression, and number of things precisely based on what you are doing with your data. So that was not only the change of the file system as well as the compression. I also changed the, did some optimization on the joins also in Hive. But I'm just giving you an example how drastically you can change your processing time in the cluster with understanding the things. So it's not only the compression and the file format which I changed over there, but I also optimize the joins. So, but still, you can drastically reduce your processing times and things like that. You can drastically reduce your cost of the cluster. You can drastically reduce the because when you're reducing your data 78%, you're practically reducing your data 78 into 3% times. So if you're saving out of 585 GB, you are saving approximately 400 GB over here. Practically, you are saving 400 GBs. Your data is default replication is 3. So practically you have saved approximately 200 GB disk space. So any other questions on this file formats? Anything?
Nope.
Practically, you will not be looking into that, the technical side of the file. You will be using these files to store the data. I might use a doc or PDF. Only thing which I want to understand is I can change the doc with the help of Microsoft Word, and I can't edit the PDF without a PDF editor.
So, Miraj, this is Umesh. I think I've been kind of like listening in and off, but I had a question on the way you kind of like modify a row into a column, like basically the way you read it and store it. So how do you actually, let's say you add a new row, and how does it actually go and get into this format, into a vertical column format? That's one question. And also, when I do a join and things, how do we know that this is the end of my row? Because we all store in a vertical fashion, right? It's not a row fashion. So how do we know whether this actually has an empty row or empty value in those columns?
So how do we add the rows? Your first question. So what we do is we not only divide the file vertically, we also divide the files horizontally. So in a row group, there will be only 5 or 10 or whatever number of rows you have defined. So when I have to add it, I'll be adding it to the last row group. So, or if I basically row groups are created at the go when you're creating the file. So your row group is created and the whole row group is jumped into the file system. If I have to append something, that a new row group would be created up and that will be stored in your file system. And how this, your second question was how you will find out if some row or column is missing, right?
Yeah, basically, from a RDMS point of view, we know exactly what to join and things like that.
So
the data can also be empty.
Yeah,
so the columns can also be empty.
It's just, I am not 100% sure about this answer, but it's the same way how your other file system understand if something is empty over there, that will be empty over. So if some column is missing from here, or if this column is missing, so this entry would be missing over here. And if say my file is a comma separated, this nothing would be here, and the comma after that again a comma. Or if say my if my file is say tab separated, so or pipe separated, so a pipe and a pipe and nothing in between these two pipes. So I know this is nothing for this column.
So we don't have to actually go and look at these files and things. It's kind of just for a concept base, right? Because this has to be like it's all taken care by the Hadoop engine or something to read and kind of parse this data, right?
Sorry. Can you rephrase the question?
So, okay, my question is like we don't have to know too much details about how these contents are stored from a point of like doing some coding and things like that. It's actually already given by the Hadoop engine, which is going to read all these files and do the necessary queries.
Yeah, practically you will be using the predefined readers or writers for these files. You don't have to understand those things, but for how the space is not so in the Oracle, I think that particular space is left behind. So you have what we call those holes or so, I cannot recall the technical term right now. We have those holes or things like that. But over here, if some data is not there, so practically I'm storing that thing something at the backend in the file system only. So that's a kind of text file or some similar file at the backend. So my data would be having some separators. So here the separator was comma say. So for each after end of each row group, my separator is this thing semicolon. So I know when the semicolon is there is a no new column group which is started up, and the row groups are separated by some other thing in the file. So there are three separators in my file: comma, semicolon, and say slash and for my row group. So if I have to read some another row group, I'll just search for slash n. If I have to read some particular column, I know that the columns are separated by semicolon. So if this read the first column, this is the first column, this is the second column, this is my third column, and this is my fourth column. And if I have to read some particular row from that column, I know commas are those things, separators. So at the back end, your files are stored in the file system only. So like these files were stored in the binary format, sequence file or map file. That's the reason if you remember, I used Hadoop FS minus text rather than cat. So there I used the native libraries to read the file and convert that to text format to read it. These files might be stored in a text file format only, and then you can use the simple text files to store these kind of files also. Although you don't have to worry about any of those things, that will be automatically converted up, and you have to just store and read it. Everything is at the back end is done by the beauty of the system.
Okay.
Okay. So any other thing before moving on to the new topic?
Nope.
Okay. So just give me a sec. Let me open a new PPT, and I'm just pausing the screen share. So let's start Hive. The Hadoop streaming will look later on. Let's talk about Hive today, and then Hadoop streaming I think will take it on. Let's talk about Hive.
So can you share these presentations?
Yeah, I'll share the thing. So others previous to that I've already all shared in the PPT folder. This one which we covered today, the compression, the file format, I'll share it. Okay. So why I started Hive rather than Hadoop streaming is because this gives you till now you're just looking at a system and thinking of what is the system. Although we looked into the MapReduce part, but how these different technologies on top of MapReduce are used to make your life easier. So Hive will is the is much familiar with all of you, because all of you have the familiarity with SQL kind of syntaxes. So Hive gives you a SQL kind of syntaxes on your algebra file system to query the data. So let's look into the Hive. That will give you much better insight of the system, as well as what we were looking at the file formats and the compression. If you use them, that will give you more picture of what I was talking about. But we have to understand those file formats and the compression to use them over here. If you would not have understood those things, nothing would have made sense over here. So that's the reason I've covered the compression file systems prior to this. But let's look at the Hive. That will give you a real picture of how we we really query the file algebra file system in a much easier way. So Hive is developed at Facebook, used in majority of the Facebook jobs. It gives you a relational database kind of feel or built on top of Hadoop ecosystem. You can write SQL kind of queries to read your data from the file system. It supports things like your MySQL, partitioning, clustering, joins, optimization. You can create your table schema and things like that on your normal file system, and you on your normal files, not normal file system. The file system has data only on your files, and you can use them to process your data in a normal SQL kind of language. So, but now your question would be, why do we really require them when we have the things like MapReduce or things like Pig or things like that? So, the problem with your MapReduce is you have to understand, you have to learn Java, you have to write big Java codes to do all those processing, and you have to do some join between two different files. Again, that's a big job which you have to do. So the development cycle and things like that over there is pretty large, but in Hive you have to just write a simple query in a SQL kind of format, and all the things would be done. How that is done, I'll talk about those things. So what Hive does is, at the backend it will create a MapReduce code. It will run your MapReduce code at the backend, everything transparent to you. As a user, you will just write a query where your query is nothing but interaction with your files, with your real data, which is stored in the files in SDFS, and you just write queries like select star from table so and so, where clause, joins, and things like that, and you get the data. So before going into the real Hive concept, let's look at one hello world of MapReduce thing which we ran up. So if you remember, we created a MapReduce program where we did a word count. So if you look into that program, that contained around 60 to 70 lines of code to just generate the word counts in my file. I hope everyone remembers that, right?
Yeah.
Okay. But the same thing I have done in the Hive with a single line of code. And before that, we created, we used one more line to basically create a table on my file. So we used 2 lines of code and everything is done for us. So I will just run this command in a minute. So what we are doing is, we are over here, what we are doing is we are creating a table named doc. Here I am defining some table properties, and here I am loading the data into the table. I could have given the location over here only. So this line would also have been saved. And in this line, what I am doing is I am running a query on that table. What is this literal view? What is this export? Don't worry about these technical things right now on the first slide. But this is just an example which I wanted to show you how that 65 line code of Java could be reduced into two simple lines. I've created a table on my text file where my text file is stored at so and so location, and I'm just running one query on top of that file where I'm saying the word and the corresponding count of that word and grouping by word. So for each word, I'm just printing out the number of times that word is occurring in the file. So let me try to run that and show you how the Hive looks like, and then we'll proceed further. So to go to the Hive console, what you have to do is just type HIVE and press enter. So it will take a little time, and it will take you to the Hive console. And the Hive console, you will see Hive and that greater than less than kind of sign. So it's just taking a little bit more time to go to the console than as usual. But I'll wait for this guy to go. Okay, so now I am at the Hive console, and over here, I hope everyone have used MySQL kind of thing, right? Anyone who has not used MySQL?
MySQL or SQL?
Microsoft SQL, anything, Oracle, Microsoft SQL, MySQL is a freer version, so I hope at least the MySQL.
Yeah, we have used database SQL kind of queries. Yeah.
SQL kind of queries, but MySQL is a freer version, so most of the Hive queries are most aligned to the MySQL. And if you move on to the Microsoft SQL or Oracle, some rare things might change. But most of the commands are similar to what we use in MySQL. So although those are similar across Oracle also and any other SQL kind of structure, but these are mostly aligned to the MySQL one. So here we can create the databases, tables. I'll show you all of those things in some time. So, let me create the table on some file, and for that let me look at some file in my file system where I can create that. Let me see if I've given some example here. Okay. Do I have the word count program where? Okay. I'll use that only, but before that let me just search some file. Just give me a minute. Let me just look at some file on which I can create this. I'm just a sec. I'm just searching for some text file. Okay. I got it. So I've got the location. We'll use this thing. Hadoop fs minus ls and oops. So here's some text file. We'll use it. I think we use the same thing when we use the word count for MapReduce. So we'll use the same file. Okay. To create the table. So rather than writing that whole command, let me copy this thing. So yeah, this is the file. Okay. So I'll use the same file. And I'll just say location. So what I'm doing, don't worry about that part, but I'll explain you. So I'm creating a table. If the table is already existing, it will give me an error. So I just said create table, table name, and this is the column in the table which I've given, only one column with the name text and of type string. Row formats field terminated by, I'll talk about that thing in some time. And there's a location which is pointed by this table. So this table is pointing to this file. So it says okay, so file already exists. Okay. Create table. Hello. I'll load the data. I'll use the easy way.
No. I think exist or exits. I think you gave a typo.
Okay. Yeah, I gave it. What happened here? Load format, metadata, high QLDL.
The input looks like the input needs to be a directory, not the file. That's what that exception is saying. Parent path is not a directory. Or check
sorry. Yeah. So you cannot create a table on the file, and I gave this to. I gave this whole part. So I can give a directory.
Yeah.
So I'll just copy it to some other thing. So I'll copy it to the output. I'll copy it over. So that is deleted. Man, what happened? What happened? Use the whole folder. What I deleted? Shit, man. I deleted the whole data. Did I delete the whole data? Shit.
Can you check under Hive directory? Maybe there?
No, the whole design Pathshala folder I created, I think, or deleted. Okay, not a problem. We'll create a file. Not a problem. I'll create another folder, not a problem. For timing, I'll just create a one. So here I'll create a new file for timing.
But I thought you selected under DP output, you selected the data and
yeah,
index.
I am not sure. I think I pressed back something wrong. I pressed over here. I don't know, but I don't want to waste the time. I don't. Let's create a new file. Let's just take a minute. So
you can if you lost the data,
yeah, when you get the data, by default it will be in your trash. You can recover it, but I don't want to go over there right now.
Okay.
Okay, let's save it. Few spelling mistakes, not to worry about that. Okay, so user UDP will use this. Okay, so because the data was deleted, I'll just cross check it over here also whether it's really deleted or we are getting some problem on the view side. So I'll quickly look over here. Otherwise, if I start reading such a big amount of data, again it will give a problem with such a small machine. Okay, the whole data was deleted. I don't know what I did, but not a problem. Let's we've created this table, and if the table was already existing, it would have been the previous table which was used. So I'll just before going ahead, I'll just cross check if the table is really created or it just ran the query, because I gave this clause also if that does not exist. So I just say if you have worked on MySQL, you can understand what command I'm writing right now. I'm just saying show create table, so this will give me the syntax of the table which was used to create this table, and it's pointing to the user UDP only. This is good. So now let's run this thing. Select, and it will print out the. So my okay. Let us select run. I wanted to show you the data from this table first off rather than running this select query, but I just ran that. So I'll show you the data also in a minute. So here it's now, if you can see, the MapReduce job has been triggered up. It will do all the processing for you at the backend. It will create all the Java files for you at the backend or do everything for you. It's everything transparent to you. You don't have to worry about anything. Only the thing which you have to worry about is where your data is stored, which I've given it over here. How my file is looking like, how my fields are terminated by, that I'll talk about these things. These are the only things which you have to store about. Rest everything is taken for you. So if you can see over here, your output format, your input formats, all things are default came over here. Input format, output format, which I was talking MapReduce first, everything is default is taken care. Text input format, text output format, the default ones, the location, table properties. We'll look into these things. But it's creating, it's running on MapReduce job to do this for you, to do this thing for you. So it's running the job. It's taking a little bit more time because a lot of things are running on my PC. So let me close them so that it gets some breathing space.
So meantime, can you explain the SQL?
Okay, yeah, oh, sure. Just a sec. Oh, okay. I'll increase the RAM also later on. So in the SQL, what we are doing is, where's it gone? So in the SQL, what we are doing is, I don't go over here right now. What is lateral view? What is export split? Uh, it will make more sense when we learn Hive. But in the SQL, what I'm doing is I'm grouping them by the word, and what I'm doing is a simple word. Each word I'm printing the word and the corresponding count of that group. And there's some logic over here. What is there? I'll explain that thing, but it will make more sense when I talk about what is Hive and other things. So this is a literal view. And explode is basically I'm creating a dummy table over here, an internal table over here, and which is doing nothing but exploding my text based on each space, and that space is used. So this is the table name which I've given for this internal table, which is created with the help of this lateral view explode, and I'm using that word over here and the corresponding count, and I'm grouping it by word. So for time being, just ignore this complexity. But here, just understand, I'm just grouping the things. Somehow I've written this logic to figure out each word from a text file and grouping those words and printing those counts. And I'll explain these things once you understand everything of Hive. I'll explain this thing also. But this thing is basically I'm creating some dummy table, doing explode, and explode is nothing but to explode your data based on some split criteria which I've given over here, or any criteria which is given over here inside this explode. So these are the few words which I've given over here, and the corresponding counts are here. At the backend, it triggered all your mapper, reducer job, created your keys and values, everything get transparent to you. You got your output in a simple format. Select the star from something. If I look at the table, select the star from doc. So see, it printed the whole file because there was only one column which was pointing to over here, and the rows are terminated by /n, so it is the first row and the second row out of the file, and everything is here for me. So it supports all your data types. What you can what are someone left? Rajesh, are you there? Okay, looks like he left. He'll join.
I'm here.
Okay. So it supports your different data types. These are different data types which it supports. Ends, begin, boolean, float, string, timestamp. Other than that, it also supports some complex data types like structs, maps, and arrays. Structs, maps, and arrays, I'll just talk about in the next slide. So, okay. So we'll talk in this slide what is struct, maps, and arrays in the next slide. So similar to your SQL word, you create the table. In the previous example, we created the table. We can, so table will always be pointing to your some directory in the executable file system, and that is what we did in the previous example. That was we pointed that to a directory called user/u/db. So all the files inside that directory will be read as a data for the table. And that is what we did in the previous example also, and there are other commands associated to a table. So here I am creating a table on a file and so here I am giving different column names. So column name. Any questions? Okay. So here I am giving column names to the data which is lying in my file. Column name, salary, subordinate, deductions, address. This is how I can give the comment to my table, which is nothing but a comment, so that later on it could be used for referencing or knowing what is this table for and things like that. Partition by is to partition the data. So you can partition your data so that your data would be physically partitioned into different directories. We'll look into the partition by in detail. Row format delimited is the thing which you tells Hive how to read your data. So this is a delimiter which Hive will be using to segregate your columns or rows. So now here I am saying fields terminated by /001, which is nothing but control A. So what I'm saying is my fields or my columns are terminated in the file by control A. Corrections terminated by control B, that is /002, and maps keys terminated by /003, that is nothing but control C. So map key and value pairs are separated by control C. The collection items or the things like structs are separated by your control B and by control C, and your lines or each new row in the table is segregated or delimited by /n, that is a new line, and my whole data is stored as a text file. So these are the control A, control B, and control C. Let's look in the real data how the data is there. So your data is data over here is something like this. Your Joe A is the name first column. Your row fields are terminated by control A. So this is terminated by control A. So it's the control A after this. Your first data. Then you have the salary. So here's the salary. Again terminated by control A. Your fields are terminated by control A. Then we have subordinates. The subordinates who are subordinate for this employee. So that is an array. So an employee can have n number of subordinates. So we have defined that as an array. And as I said, collections are terminated by control B. So if there are more than one value in this array, those will be separated by control B. So here Mary Smith and Todd Jones are separated by control B. So all of this thing is separated by control A. So this is a new field, but the thing is that the arrays are kind of separated by control B. And then we have the deductions, which are applicable on their salary. So this is again a key and value pair, the kind of detection and the corresponding value, and keys and values of maps are terminated by control C. So federal tax value 0.2 segregated by control C. Your collection items are terminated by control B. So key and value pair of a map is again terminated by control B, and so on. So these are the terminators or separators which I have defined in my file. You can always change them. You can define them n number of things over here. You can even use comma, semicolon, anything over here. Only the thing which you have to ensure is your data is segregated by those corresponding delimiters, and this is how Hive will read your data, create your corresponding columns and rows, and you can run query on the data. So in that previous example, I used that explode because I do not have those kind of separators in my file. So I use that explode lateral view to generate some internal logic to export my data into that corresponding format. Now is this thing clear to everyone? Your data is at the backend practically written something like this in a text file. I have the corresponding separators in my data, either a comma separator, tab separator, anything. Here I am using control A, control B, control C, and the reason I am using control A, control B, and control C is because if you don't define the terminators, or these are the default one which Hive gives you. If you create the data or insert the data into the table, these are the default ones. If you don't define them, You have to define the separator always in Hive, but these are the standard of Hive. So these are the standard control A, control B, control C, and /n as a standard terminator for any table which you create in the Hive. And this is how your file will look like if you are using these kind of delimiters. And this is your command to define your delimiters. So this is how you create a table in Hive.
The partition by department is not a column, right, in the table. So what does it mean?
Okay. So a partition by is basically used to partition your data on a particular column. So the table structure in the Hive, what we give is, if my data is partitioned by something that is not in your columns, but that is a separate thing which we define over here. So your data also have a department as an attribute, but that is used to partition your data. So your when this data is stored in your SDFS file system, you would be having n number of folders inside your yeah.
Can you repeat that last statement because it went blank?
Okay. So what I'm saying is, okay, just a minute. Let me open an Excel sheet and just give me a sec.
So when you select star from the table, will it also show the department as a column?
Yes, it will show.
Okay.
Okay, I hope you can see my Excel sheet. So say this is my SDFS location, user/use/dp, and here is my employee table stored up. And my employee table is partition on department, so it will contain say it's partition on date, or say it's a partition on department only. So I have employee departments APHY, physics, chemistry, mathematics, and so on. So these are the different folders inside this directory, and this folder would be having the corresponding data for the physics department. This folder will be having the data for the corresponding chemistry department, mathematics department, and so on. So our data.
I think if the department is in the column, I think then it's okay, it's fine, right? Because I don't see the if there's I understand that part, because it's all based on the partition key of a department, right?
Yeah, but that is not defined in the columns. That is defined if you're using some attribute in your partition value, then that is not defined in the metadata of the table. However, when you do a select, that will be visible in your select query.
Okay.
And how if you have raised that point, although we'll be covering that partition later on, but let me tell you one more thing over here. So when you really create your partitions, although you can create it something like this, but the practical suggested way in Hive is to give the folder name is something like this. So we have the column name equals to its value, column name equals to its value. And how that is useful, I will talk about that thing, but this is how it's practically suggested to have in the Hive. That's a kind of standard which you should maintain. You could have given it physics, chemistry, or mathematics also, but department equals to physics, department equals to chemistry, department equals to mathematics would be much useful for you. And that is also one of the reasons why that is not visible over there. And but when you do a select, that is visible in the select. So your data could have been stored something like this in the JSON also. There also only the thing which you have changed over here is rather than using this text file, you could have used the JSON as a reader. We'll look into this, and you could have read the data in the same way. So let's look into the how you create a database. So similar to your create table, you create a database, create database, database name, create database. If not exist database name, show databases will show you all the databases inside your inside your Hive. And previously, when I ran the doc example, if you can recall, I did not give any database. So everything is ran inside the database called default. If you don't create any database or choose any database, so to choose any database, you have to just say use and the corresponding database name. So show databases like bstart will show me all the databases which are starting with D. The default location of a database where it is created, if you don't define it, is inside at this location apps hive warehouse and the corresponding database name .db. This is again a configuration parameter, but this is a default one. I'll just show you how to change this configuration parameter in a minute. So this is another way to create a database. Create database, design Pathshala is the database name, location where this database should be stored up. In this example, first line I have given the database name, but I have not given the location. So the default location which using up the app hive warehouse and the database name .db is the folder which will be created for you for this database at this location. Again, this is a configurable thing, but I can create it any other location. I can give my location. I can give the comment that is nothing but a kind of command to remember what for this database was created. We'll just run few of these commands in a sec. Describe database or describe table will describe the database for you. Describe table extended will make more sense. I'll just show that thing also to you in a minute. Describe database extended, although that does not give much detail because database does not have much attributes, but table will make more sense for you. And drop database is basically drop a database. What is the set command doing? We'll just talk about that thing in a sec. So here if I say so it will show me all the databases. Right now there's only the default one which is over there. If I say I'll give a short name. It created a database for me, and now so it's created. I say describe db. Sorry, describe. So it shows me describe database. Describe this is the location at which my database is created. Apps hive warehouse dp.db is the folder name which is given for this database. So all the tables, if I create inside this database, would be created at this location. I can also give that the folder outside this database to find from a table, but this is the default location which will be given to any table if I don't define the location inside the table. And a describe extended will give some other features, but in the database there are not much features, so that will not be visible. Extended I'll show in some on the table part, that will make more sense. And what I was saying, okay, set thing. Okay, so you can set the different parameters in the Hive, and how to set them is just say set the parameter name. So over here, what we're looking at is ICLI current DB. So this is the parameter. If I say colon and press enter, it will print the value of that parameter. So it says this parameter is currently set to false. I can set it to true just by saying equals to and not set to true. So now it's printing the database name also with the Hive. Previously it was not printing it, now it's printing the database name also. Now if I say use DP, I'm moving to the design Pathshala database, and now it says. So this is how you set any parameter in the Hive session which you are running up. There are other ways to run the Hive queries also. We'll look about them also in some time. But when you are doing say a development thing or things like that, you will be using this Hive console to run the Hive queries. You can actually run them from the file like you run in your MySQL, just giving the MySQL -f command. Similar way you can run in Hive also. I'll just show you those things. It's pretty easy, very much user friendly. At the back end, it will do all the work for you. Only the thing is you have to remember how your file looks like. You have to create your relational structure on your file, and rest everything is done for you. So before I go ahead, do you want to just open your console and try just run one Hive command, or shall I continue?
I think you can continue, Miraj.
Okay, sure. So table, we have just seen the table command, how to create a table. So create table if not exist, the column names, comment, table properties created by and things like that, location, where my table is pointing to. We just run this thing, and this is how I can create a table. Similar to database, we have the commands like create table if not exist, like. So here I am giving this table should be created like some other table. So all the properties of this table will be used to create that table. Employees 2. Show tables will show you all the tables in the database. So tables in my DB is I'm pointing to some other DB from where I want to show the tables. Tables, show tables starting with DSI, it will give you all the tables starting with DSI. Describe my table will give you the definition about the table. Describe extended will give few other features. So use So see, it gave you the detailed definition about the table, doc, these are the columns, the table owner created, text input format, text output format, SQs, partition keys, if they were partition anything, manage table. What is manage table? I will talk about that thing. What is manage table in a sec. But it gives you all the detailed structure of the tables. Number of buckets you can bucketize your table also. How to bucket them? We'll talk about those things. The location where the table is stored. So okay, so there are two kind of tables. Try to understand this thing. This is very useful. There are two kind of tables. One is what we call managed tables or intent tables. And there's another thing what we call external tables. So the major difference between your managed or intent tables and the external table is when you drop your managed or intent table, your data is also deleted by the Hive because the tables are managed by the Hive. Those are internal to the Hive. However, when you drop an external table, your data is not at all touched. That is a major difference between a managed or internal table and an external table. When you create your internal table or the managed table, location is not defined. You just create a table. Your table would be created inside your database folder, but you can point. So in the first example, I pointed it to some directory lying in my SDFS world. So that is a table which was created outside my default database directory, and if I drop the table, my data would not be touched. but when you drop these internal tables, my tables would be deleted as well as the data would be deleted because these are managed by Hive. So how you create your external table? It's little different. External tables point to an existing directory in the SDFS file, can create tables or external partitions also, and this is how you give it: create external table. So by default you have to use this keyword external to create an external table, and you give the location and to which directory of table is pointing up, and it would read the data from there.
So with an existing file, you can create both internal and external tables.
With an existing file, we can create both internal and external tables. If you don't give, see the thing is, let me talk about the terms how you will be working with your data. Practically, when you will be running a data pipeline, your data would be coming in some directory. You'll be creating a table on top of that. When you are creating a table on top of that, you are defining the location while creating the table, pointing to the correct to the directory. So that table is a managed table, but as the table is pointing to some external directory, that data will not be deleted for you by when you drop the table. But when the data is created by Hive, there's a little twist over here. When the data is really created by Hive, then when the Hive is having the ownership of the data, then the pipeline say you are managing, you are doing some segregation or aggregation on the table, and you create another table, say select some salary group by employee from table which I created just now, and I'm inserting the data into some another table. So that data is really created by Hive, and Hive has an authority on that data. In that case, when you will be dropping that table, you would your data would also be deleted. So even if you don't use the word external over here, but you're pointing to some directory of from where you're reading the data, when you drop that thing, that data will not be deleted for you.
Okay, so the reason I asked that question was, we created that word count file, right? And then you created the table without the external keyword.
Yeah. So if
you drop that, if you drop the table, will the file that you created also will get deleted?
Hive do not have authority on that file. Hive is not the owner of that file. That will not be deleted. That's why. So I understand your question, and that's the reason I gave you the logic why Hive deletes or manage data and does not delete or external table data.
Okay, so in our case, whatever example we ran, it created an internal table but also copied the data in its own table structures.
No, it does not copy any of your data. When you've created a file, when you've created the table pointing to some directory, and nothing is copied, nothing is copied to some other location. Although I have not given the word external, but that is considered as an external table because my data is lying somewhere external outside of my Hive warehouse.
Okay. So it's not entirely true that when you drop a internal table, it will drop the data also. It depends on how the data is getting pointed to.
Actually, the major difference is not just the external keyword, but how your data is pointed by the Hive.
Okay, got it.
So the external tables will always be having this location criteria when you create your external table. This is the most important thing. So here what I'm doing is create external table. If not exist some table name like some other table location this. So my table will be created using the metadata of this table, but it will point to this location in SDFS. So these are the different commands which you might be using. I'll just keep on giving you hints how the different commands look like. I will also run these commands. So here we are doing the partitioning. Okay, before that, let's try to run some of them. So, okay. So here I am creating some external table pointing to. Now I've deleted the whole data. Just give me a minute. Let me recopy this data. I'll just copy it in a sec, and then I will be able to show you these examples. Another way to run these commands is, sure, Basha, you can drop off, but we'll be continuing for next half an hour more. So
yeah, that's what I'm yeah, I have some work today this morning. I'll drop off and then we'll be joining tomorrow. Okay.
Sure. So now this is a SQL file which I've created up with Hive command inside it. So one way is copy this thing, paste it into Hive console. Another way is I can give Hive -f and the file name. This will trigger the Hive console. This will trigger this command on the basically will pass this whole SQL query to the Hive word, and Hive will run this thing for you. But before that, this location is right now is not existing because by mistake I think I've deleted all the data. So just give me a minute. Let me recopy these files from my local file system to the SGX file system. It will take a minute or so. So I'm just pausing up the screen again, and then we'll run these examples. So just copying up, just a minute. Okay, so here it is. So I'll just copy. I'm just putting the data back into Hadoop word on which these examples will run. Okay, so it's copied. Now we should be having the data over there back. At least I folder, yeah, it's there. So this is what I'm concerned right now, and rest all is of no use to me. So if I say so first what we are doing is we are creating a table which is pointing to this location. and there's some file lying at this location, stocks. So you can see this is the comma separated file. So what I did is I use row formats field delimited by comma. I have not given the rows terminated by, so slash n is the default one which is taken care, and slash n is the considered, and each of these things will be considered as a new. So all I have to do is hive minus f and give this thing. It will trigger, send this file to your hive. Hive will run it and everything will be done for you. Or I would have copied it to the Hive console, both the ways, but the table will be created for you. I don't know, it's running so slow today. So I wanted to show the partition example. That is what I wanted to show you. So after this, I'll directly switch over to the partition example. So, partition you would be using up by the time it's running up. Partition you would be, partition bucketing are the two most important things which you would be using up highly in your data. When your data is coming up daily, ensure that you partition your data based on date. Your data is partitioned on year, month and date. That will be highly useful for you when you are running your real queries. If your data is not partitioned up, at a time you are, your single query is seeking your petabytes or, gigabytes or terabytes of kind of data. And it might take hours to just, run your query. But if your data is partitioned up, your joins are in between partitions on different tables, and your joins would run much faster. Or not only joins, your where clauses will also run much faster because you are looking only at a particular folder inside your whole data lake, or whole ocean of the data of your table. So it's always suggested to have partitions and use partitions. Not only partitions, buckets also. What is bucket? I'll talk about it in the next few minutes. But always use partition in your data. So this is a table which is created. If we look at this table stocks, so stocks is there. Sorry. So see, the table is dropped, but the data is there. So let me show you the partition example. This is the entire table example. I'll just show you the command, but will not run it. So create table internal like stocks. I'm just creating another table. Populating this table. What I'm doing is, again, I think insert into this table, so I start from this table. So this is how I'm inserting the data into another table from this table. So I've created in an internal table and storing the data inside this internal table as a select start from my stocks table, which was my external table. But when I'll be deleting this table or dropping this table, my data will be deleted up. And wherever you want me to run any of the query, do let me know. I am just skipping few of them. If you want me to run them, just do let me know. I'll run them. But the silence really kills me. So here what I'm doing is I'm creating the table partition by date, and again the same stock kind of table where I had open price, high price, low price, close, and the volume and the trade date on which my trade happens. So here I am not using the trade date as a column, but I am using trade date as a partition key. So what I'm doing is I'm creating a table, if not like this stock partition, and I've given 4 columns over here, and I've partitioned my table based on the trade date. So my data would be divided inside the different folders of trade date. So let's create it hive minus f and partition, and then we'll populate some data inside this table. Right now there will be no data inside this folder. So where we have created hive warehouse something now. User hive user warehouse. What is the location? Users. I'll check it over only. So you don't have to remember any of these liquid locations also, where the default warehouse location and things like that. All you have to do is just describe table and you would be able to see that. Or there's another way. I'll just show you that thing also later on. There's one more way how to get it. Okay, so this is created. The table name is stock partition. So I said describe table name. Now see, I use the describe table name. It shows me the table information, the partition table, but it does not show me something which I wanted to check with the location. So what I say is describe extended. Now I'll be able to see the extended attributes about my table, including the location and the default location F's hive warehouse DPDB. So let me go there. So this is a folder by the name of the table which is created for me at the location of my database. And now let's try to insert some data into this table. So what I'm saying is, what I'm doing is dynamic partition non-static. I'll just talk about that thing. I am inserting some data into my partition table, and what I'm doing is select from my stocks table. In the stock table, I had the data of my stocks, including the trade date. So I am defining the partition column from this table, which need to be used the trade date only, which is the partition of this column. So I'll run this thing and see what will happen.
But you dropped that stock table, right? So there won't be any table.
Did I? Okay. Yes, I'll create it again. I minus. So what I'm doing over here is the dynamic partition mode non-stick is basically, by default the dynamic partition mode is stick. What is dynamic partition? We'll talk about that thing in some time. So here I'm setting some attribute of the hive the way I did on the console, set the attribute name and the corresponding value. So I can give it in the file also, and when I say hive minus f, so these will be ran in one by one. So this thing would be available in a session. This attribute value would be available in a session and used by the hive. So by default it is stick, and you are not allowed to use dynamic partitioning. What is dynamic partitioning? The partition is dynamically created on the fly. I'll talk about this thing. What is dynamic partitioning? I'll show you an example in some time. So what I'm using dynamic partitioning. So my table is probably created by now. Yeah. There's one more way to run the Hive queries. Another way is Hive -E. So with the help of Hive -E, I can give the command directly over here, and those will be triggered to your Hive. So I can give it something like this also. So there are three ways you can trigger the Hive commands: Hive2 from the Hive console, Hive -F, give your Hive files, or Hive -E if you want to run some particular command directly from your Unix console. It's running up at on the fly. It's choosing the partition value. What is the partition value based on the trade date, and that is called dynamic partitioning. I could have used a static partitioning. Over there, I would have defined the partition value as a static overhead equals to something, and that would have been a static partitioning. I'll show you that example in some time.
But quick question, the stocks partitioned already defined when you created the table, it already defined partition by trade date.
Yeah.
The stocks table has a column name which is with a lowercase d. Is that why you are saying partition?
No. That's case insensitive. So here what I'm saying is this partition trade date is the trade date column of this table, which is used to partition the data while I'm inserting inside this table.
But shouldn't it automatically identify the column names?
No, the column names could have been different. So that thing you have to give it explicitly over here. So if you don't give it over here, right now you will give it a get an error that you have to define the partition key.
Okay.
So, but see now my data would be partitioned up. There will be different folders which will be created for each trade date, and those. So practically, you know what is another purpose of me showing this example is practically when you are partitioning your data, or doing something on your data. Say you get 1 petabyte file, and you want to partition this file. So practically you will not be you will be using such kind of Hive queries to partition the data, so that later on when you are using that data, your queries are faster up. And each day now you will be creating only another folder of the day, and your data will be stored inside that day, and your older data is partitioned. So these kind of queries you could be running up at the back end to do all these things. That was another purpose for me to show you, rather than me myself creating a number of folders and putting file inside that. I wanted to show you how you can, Hive could be used to do all these things for you. Strange. Okay, so let it run in the backend. I'll just show you that thing in a minute. By the okay, it's done. Map is 100%. Reducer won't take much time for us because we are not doing anything like reduction. So this is one. It's too slow. Actually, I ran it on just on 4 GB RAM. That's the reason it's too slow. I normally run it on 8 or 10 GB RAM. Okay, by the time it's run up, let's look into some of the things. So what I was saying is your data should be stored something like this. So here what I'm doing is I am saying my data is partitioned by country as well as state. So at the end or in the file system, your data would be something like this. Employee, country is a top level partition. The state is a partition one step inside the country. So your folders would be something like this. Top level folder employee. Inside that folder is something like countries equals to CA, countries equals to US. Inside countries equals to CA, folders like state is equals to AB, BC. Inside countries equals to US, folders like state is equals to Alaska, AK, and things like that. So this is how your data partitioned up, and when your data is partitioned up, this is how your folders would be looking at. And when I'm running a query something like this, select start from employees where address is equals to US and state equals to Alaska. It will just go to this directory and will just read the smaller files which is lying inside this directory rather than looking at whole of the data which is lying inside the employees directory. So let's run. Still running. Okay. Let's run. Loaded partitions. So see, all those different trade dates are now become the folder names. And if you look at the file, see the trade date is not there in this file, that is removed from the file. However, that was there in the original file. And that answer, I think, the question which someone has raised, why the column is missing, because the data now does not contain that data, the real file does not contain that data itself. Is the partition key in the value now. So that's a reason that is not appearing in the metadata as well. So however, if you remember, the original file has a comma and the trade date at the last. So, okay, so one more thing which I forgot to tell you, which I was saying today. Another way to find out that where is my default location of warehouse or things, what are the different attributes of Hive, or look into that. What you can do is Hive -E, and set is a command to look at all the parameters. Set, that will give me all the parameters, Hive and their value. So Hive -V, E, again, I told you five minutes back that there's a way how you can look at how you can run the Hive command. So set is a command to look at different parameters in that Hive. If I give set over here, it will print all the parameters like this. So this is what it will print also, but it's taking a little time to communicate with the Hive client to Hive server, and getting the response back. So now the easiest way to search different things is okay. So now say I want to check the warehouse. What is the default location of warehouse? Grab and warehouse. And I just will give minus. So this is another easier way, because over here if you give set, you can't grab anything over here. It will give all the parameters, and if I want to check something I can't. So better way is use Hive-E and grab the thing. You know what you are looking at. If you want to look at some parameter, something, some library, something, just grab that thing, and only those things would be visible to you. So this is the easier way which I just want to tell you. So here what I'm saying is select start from employees where country equals to US and state equals to IL, so it would be only looking into that corresponding partition, and your data would be much faster. So Hive set mapnet mode is correct. So this is the default setting in the Hive. If you can change it. What does this mean is it says your mode is strict, means if your table is partitioned and if you're running from where clause on the table, it's mandatory for you to use the partition key in the where clause, otherwise it will give an error. So you can make it non-strict by changing this parameter, but by default it's strict. And if your table is partitioned up, you have to remember to give the use the partition in the where clause to make your queries give better performance. And you can make it non-strict and then run it. If you run this query right now without using the partition as a key, you will get an error something like this. But if you make it non-strict, you will not get an error, although your table is partitioned, but I'm not using the partition as a key in my where clause. Show partitions will basically show all the partitions on my table. What was the table? Stop partitions.
Partition spelling is wrong.
That's correct. That's wrong.
Partitions, T-I-T-I-O-N. T-I-T-I-O-N. Partition. Yeah. T-I. P-A-R-T-I-T-I-O-N-S. There is no I. Sorry, okay. There is no A. I.
P-A-R-T-I-T-O-N-S.
Yes. P-A-R-T-I-T-I-O-N-S.
Now you confuse me. Is this the correct one?
Okay, P-A-R-T-I-T-I-O-N-S.
Okay. So it shows me all the partition on the table which I created up. And okay, we'll talk about that. What you can do with partition, different things. So partitions employ the partition. If I'm giving partition equals to country equals US, so it will show me all the partitions inside these partitions. Partition external table. So the problem with the partition external table is you have to create your data in that format that is partitioned up, and that's what I've shown in the previous example. Always you can use Hive to do the partitioning for you. And what we did over there is we used another table to insert the table into the partition table, and my data is partitioned with the help of Hive. And describe extended we just show. If I say describe extended, that will also show me all the parameter, all the things about my partition. Okay. Serialization, deserialization. So you can use different serializations and basically Saturdays to read and write your data. So here I am using sequence file. So if you can recall, we created a sequence file in the last PPT. So we can use the input and output file. While creating the table, you have to just define stored as sequence file, or you can define the input format and output format which need to be used, and the rest of the thing would be done for you. So only the thing which you have to remember is which kind of file format you want to use it, or your data is in, and you have to just define that use those corresponding input and output file formats, and that Hive will read your data. So if I go over there, so here what I'm doing is create table if not like this sequence file. and I've given the input and output formats which need to be used for this table, and I'm inserting some data into this table. And what I'm doing is I am selecting some data from a stocks table and inserting into this table, and this table has only two columns, key and the value. So I'm just selecting keys and some two columns from this table and trying to run it. So what happened? Not very okay. This thing comment gave an error. It's doing that, and it will create a sequence file for you. That is what I want to tell you. Although I've used the Java code to do all those things, but those things are pretty easily created for you with the help of these things. So it will create a sequence file for me, and the data would be stored as a sequence file. It might take some time to run up, so we'll look into this when the data will come up. Here I am using Avro, so I am just giving the input file format as an Avro container, output as an Avro output format, and it will create an Avro for you. If I insert some data into this table. Drop table if exists, or drop table directly. Alter table, you can alter the tables which you've created up. So alter table, change column. So here I'm changing the column from our HMS to ours. So I'm renaming this column and I'm making it of type int. So when be aware of this thing. If you are doing any such kind of alteration on the table, it's your duty to ensure your data is available in that corresponding format. I will not change or touch your data. I will only and only store your metadata. I never touch your data until unless the data is created with a Hive for you. So as I gave an example of alter tables. Otherwise, it's your responsibility to ensure your data is available in that format. So here what I'm saying is alter table, change my column format from this to this thing. I will never do any validation on the data. I will not do anything for you. It will give only an error when you are doing select from the table or some operation on the table. Otherwise, it will just change your metadata safely for you when you are doing any such alteration or whenever you are creating the table also. If I say I created a table on some file and I created 10 columns on that, however file is not having that kind of delivery or things like that, I will never give an error for you. It will just store the metadata for you, and the real problem will occur when you are reading the data from the table. So if I was able to convert it to an int, it's fair enough for him. Otherwise, it will give an error to you. So the most important thing is it will always be storing your metadata, nothing else. And all your metadata is, if you remember, I talked about this H catalog. This is the person which stores all your metadata for you. So this metadata is really stored in the H catalog. If you can see, the doc table is visible over here. If I select the database DP, sequence files, these are the three tables which created just now. So all your metadata is really stored by H catalog, and H catalog is a thing which is used to share this metadata. So if I have to share this table metadata and use this metadata in the pick, with the help of H catalog, I can do that. So H catalog is now although integrated with Hive only, but with the help of H catalog, I can basically share my metadata information across different technologies. So here I'm doing alter table, replace columns, this thing with something else, this thing with something. So basically replace columns basically means all the current columns will be removed from the metadata, and these are three columns which will be added as a columns to a table. Here I'm saying alter table, table name, partition, so and so, set file format sequence file. So here what I'm saying is I'm changing the file format at the backend for the table. And so if you say till now you're getting text files, but now you have started getting sequence files, you can change the site file format as sequence file. But now it's your responsibility to ensure your files are in sequence file format. Otherwise, while reading, Hile will use the corresponding input and output file format, and it will give an error. So easier way for you, or a kind of hack for you to convert the file formats at the backend is alter the table first, change only the output file format of the table, do not change the input file format of the table. Run a command insert override table, the current table name, and select from the current table only. So while you're selecting, your input file format is the current file format, so you're reading the data in the current file format, but your output file format, say you have changed to sequence file. So when you are inserting, overwriting the same table, your data will not be now will be written as a new file format which you have defined, and later on again under the table and change the input and the input one also. Getting what I'm saying?
Kind of.
Okay, let me repeat. Say you want to change the file format at the backend. You want to do some testing. You want to change the file format at the backend. You don't want to play with the data. You just want to change the file format. So here I'm giving the set file format sequence file, so it will use the input file format for and output file format for the sequence file. What I've shown you over here. Where's it gone? Where's it gone?
Now you have to go down next 2 slides.
Yeah, here it is. Okay. So now what I want to do is, say my data is lying in the text file format. I have created a table, and the table is using text, and so this is my table, right? And now I have to think, or I'm thinking that if I change it to RC file format or sequence file format, my reads will be faster off. So I have to change the file format at the backend for my table on the data which is lying. So what I'll do is, first what I'll do is I'll just change this thing.
The output to sequence, okay.
And I will run a query something like this. Although I have not told you what is insert override, but the name itself signifies, and the table name BEST1 as start from BEST1. So insert override is nothing but it will override the whole data of this table with the new data which is selected from this query. So now what I'm doing is I am outputting my data as a sequence file. So now my new data which will be inserted into this table would be a sequence file. But when I'm reading from this table, I'm still telling it my data is written in the text file. So till the time the whole data is read, this is what is used. But to write the data, this thing will be used. And later on, I'll change this thing also to sequence file. So now my file is also, my data is also in sequence file format, and my table is also correctly formatted up. So this is the kind of hack which we use to change the file formats at the backend easily. Does it make sense now? What I was saying?
Yes.
Okay. So water table. Where else? I can rename the whole table also. Alter table this, rename to say so and so. So at all these places, I am not doing anything. Please again ensure that I am just changing my metadata. It's now your responsibility to change the data at the backend for the way you are changing this metadata. Hive is just a kind of metadata store for you, and running the queries for you on that metadata, or running the queries based on that metadata for you on the real data. So here I'm modifying my survey. So on the JSON, I'm using the JSON survey and modifying the properties of the survey. So alter table set survey as JSON and setting the corresponding JSON key to my corresponding column name. Buckets. Buckets. Let's discuss in the next class. Nothing much left. There's only few things which are left: joins and buckets. So buckets, I think let's start in the next class. Any questions till now? Anything which you want to discuss till now? I think it's pretty easy. Simple SQL commands, but at the back end it will create a MapReduce code for you, and things are very much faster as compared to your traditional RDBMS.
Okay. So can you upload this PowerPoint also along with the two others so that we can play around with the sequels?
Yeah, sure. I'll upload this thing also and try to play with them, and then the next class also I'll give some assignments so that way we can try to play with them and you can also get the hands-on because you will be mostly using Hive or Pick in your real industry.
Okay.
Sure. Anything else?
That should be it.
Okay. Sure then. Thanks everyone for your time, and let's meet tomorrow at the same time. Have a nice day.
All right.
Bye-bye.
Bye.